Good morning, my dear students. Department of Collegiate and Technical Education. As a part of LMS, I am going to explain you about transducer section 3. In the previous session, you have discussed about classification of transducers. Mainly, the transducers are classified into two types: mechanical transducer and electrical transducer. For your syllabus, you have electrical transducers. About this, you have studied all the classification of electrical transducers. In that, electrical transducers are classified into five types: active transducers, passive transducer. Next classification is analog transducers, digital transducers. Next classification is primary transducers, secondary transducers, and fourth classification is the transduction use, and fifth classification is transducers and inverse transducers. So like this you have studied five types of transducer classification in detail. So in the today's session, mm, I am going to explain you about strain gauge. So strain gauge, the content included in this session is working principle of strain gauge. One problem is there on the gauge factor and bonded resistance strain gauge, unbonded strain gauge, wire type strain gauge, foil type strain gauge. These are the types of strain gauges depending upon the wires used in a strain gauge. So next is, so let us discuss about strain gauge. Strain gauge is a passive transducer. In the previous session, I told you about passive transducers, and also I told you about resistive transducer. So strain gauge is a passive transducer. It is a type of sensor whose resistance varies with applied force. It converts force, pressure, tension, etc. into a change in electrical resistance which can be measured. So strain gauge, here what happens? Stress, strain is a very small quantity. It cannot be measured directly. Hence, the gauges are used to measure the strain. Strain is a very small quantity. So, in strain gauge, you are uh, measuring the strain. It's a micro. It's in terms of micro. So, you are going to measure uh, by using strain gauges. So, basically, the basic operation of strain gauge is, it's a very simple. When strain is applied to a metallic wire, its dimension changes. So the dimensions or displacement is measured by using a Whitson's bridge here. So changing the resistance of the wire is measured. The resistance of a wire is measured by using a Whitson's bridge. The value of resistivity of a conductor also changes. When it is strained, its property is called a piezoresistance. Therefore, resistance strain gauge are also known as a piezoresistive gauges. So, when strain is applied, force, the strain is applied on a wire, the dimension of a wire is changed. That dimension is going to measure it in a strain gauge. That is a very small change in a micrometers that can be measured by using a strain gauge. Here the very important term is strain gauge factor. So gauge factor. So the gauge factor is defined as the ratio of per unit change in resistance to per unit change in length. It is also called sensitivity of the strain gauge. ನೋಡ್ರಿ ಇಲ್ಲಿ ಗೇಜ್ ಫ್ಯಾಕ್ಟರ್ ನೀವು ಸ್ಟ್ರೇನ್ ಅನ್ನ ಏನ್ ಮಾಡ್ಲಿಕ್ಕತ್ತೀರಿ, ಮೆಜರ್ ಮಾಡ್ಲಿಕ್ಕತ್ತೀರಿ. ಸೊ ಸ್ಟ್ರೇನ್ ಮೆಜರ್ ಮಾಡಬೇಕಾಯ್ತು ಅಂತಂದ್ರೆ ಸ್ಟ್ರೇನ್ ವೆರಿ ಸ್ಮಾಲ್, ಎಕ್ಸ್ಟ್ರೀಮ್ಲಿ ಸ್ಮಾಲ್ ಕ್ವಾಂಟಿಟಿ ಅದ. ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಇದನ್ನ ಫಿಸಿಕಲಿ ಮೆಜರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. ಅದಕ್ಕೆ ಗೇಜ್ ಅಂತ ಹೇಳಿ ಒಂದು ಟ್ರಾನ್ಸ್ಡ್ಯೂಸರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಲಿಕ್ಕತ್ತೀರಿ. ಸೊ ಸ್ಟ್ರೇನ್ ಗೇಜ್ ಒಳಗೆ ಏನಾಗ್ತದ, ವೆರಿ ಸ್ಮಾಲ್ ಕ್ವಾಂಟಿಟಿ ಸ್ಟ್ರೇನ್ ಅನ್ನ ನೀವೇನ್ ಮಾಡಬಹುದು, ಮೆಜರ್ ಮಾಡಬಹುದು. ಸೊ ಇಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ತೀರಿ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಅಂದ್ರೆ ಗೇಜ್ ಫ್ಯಾಕ್ಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಸೆನ್ಸಿಟಿವಿಟಿ ಆಫ್ ಗೇಜ್ ಫ್ಯಾಕ್ಟರ್, ಸ್ಟ್ರೇನ್ ಗೇಜ್ ಫ್ಯಾಕ್ಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇದು ಏನಪ್ಪಾ ಅಂತಂದ್ರ, ನೀವು ಸ್ಮಾಲ್ ಕ್ವಾಂಟಿಟಿನ ಮೆಜರ್ ಮಾಡ್ಲಿಕ್ಕತ್ತೀರಿ ಅಂತಂದ್ರ ಸ್ಟ್ರೇನ್ ಅಂತಂದ್ರ ನೀವು ವೈರ್ ಮೇಲೆ ಎಷ್ಟು pressure, force, tension ಬಿದ್ದದ. So that is directly equal to the dimension change in that wire. Therefore, the dimension change in the sense length is changed. Therefore, the gauge factor is defined as the ratio of per unit change in resistance to per unit change in length. Therefore, the gauge factor is defined as the ratio of per unit change in resistance to per unit change in length. Gauge factor, therefore, change in resistance means delta R by R, change in length means delta L by L. It is the ratio of change in resistance to the change in length. So, delta R by R divided by delta L by L is the gauge factor. Here delta R is change in resistance R, delta L is change in length per unit length L. The resistance of the wire of a strain gauge R is given by R is equal to rho L by A. So, this you already know. What is the resistance of the wire? R is equal to rho L by A, where rho is the resistivity of a material, L is the length of a wire, A is the area of that area of cross section of a wire. Therefore, this is a gauge factor. You are going to calculate it and measure the strain. So here there is one problem. A strain gauge has an unstrained length 10 centimeter and resistance is 100 kilo ohm. When its length reduces to 9.9 centimeter, the resistance decreases to 98 kilo ohm. Estimate its grade gauge factor. Lodri, strain gauge has an unstrained length ಅಂತಂದ್ರೆ it is L. L is equal to 10 centimeter and resistance means R is equal to 100 kilo ohm. When its length reduces means you are applying a strain on that wire. Then that wire becomes 9.9 centimeter. Length becomes, it reduces to 9.9 centimeter and resistance decreases 98 kilo ohm. Then you need to calculate first delta R and delta L. Delta R, how to calculate delta R? Delta R is equal to R minus change. So, therefore, change in initial resistance is 100 into 10 into the power 3 minus 98 into 10 to the power of 3. That is equal to 2 kilo ohm resistance. Because the original resistance is 100 kilo ohm, the changed decreased value of resistance is 90 kilo ohm, 98 kilo ohm. So, you are getting delta R is 2 kilo ohm. Similarly, delta L, the original length of that wire, unstrained wire is 10 and after applying this strain, the length of that wire becomes 9.9 centimeter. So, therefore, delta L becomes 0.1 centimeter. Gauge factor, you know, delta R by R divided by delta L by L. So, the answer becomes totally, the answer becomes 20. Here delta R by R is there, ohm get cancels, length meter get cancels. So totally you are getting the gauge factor 20. So it has no unit 20. This like this you problems may get in the exam. ಇಲ್ಲಿ ನೋಡ್ರಿ ಫಸ್ಟ್ ನೀವೇನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು ಸ್ಟ್ರೈನ್ ಗೇಜ್ ಒಳಗ ಅಂತಂದ್ರ ಲೆಂತ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಲೆಂತ್ ಒರಿಜಿನಲ್ ಲೆಂತ್ ಎಷ್ಟದ ವೈರದ್ದು, ಆಮೇಲೆ ಅದರದ್ದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟದ. ಸೊ ಲೆಂತ್ ವೈರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಎರಡು ಕೊಟ್ಟಿರ್ತಾರ. ಸೊ ಇಲ್ಲಿ ನೀವು ಸ್ಟ್ರೈನ್ ಅಪ್ಲೈ ಮಾಡಿದ ಕೂಡಲೇ ಸ್ಟ್ರೈನ್ ಗೇಜ್ ಒಳಗೆ ಏನಾಗ್ತದ, ಸ್ಟ್ರೈನ್ ಅಪ್ಲೈ ಮಾಡಿದ ಕೂಡಲೇ ವೈರದ ಲೆಂತ್ ಅಂದ್ರೆ ಡೈಮೆನ್ಷನ್ ಏನಾಗ್ತದ ರೆಡ್ಯೂಸ್ ಆಗ್ತದ, ಮತ್ತೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗ್ತದ ಡಿಕ್ರೀಸ್ ಆಗ್ತೈತಿ. ಸೊ ಈ ಚೇಂಜ್ಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಮತ್ತೆ ಲೆಂತ್ ಅನ್ನ ನೀವೇನ್ ಮಾಡ್ಬೇಕು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕು. ಆರ್ ಎಲ್ಲೇ ಇರ್ತದ ಡೆಲ್ಟಾ ಆರ್ ಡೆಲ್ಟಾ ಎಲ್ ಏನ್ ಮಾಡ್ಬೇಕು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕು. ಹೆಂಗ್ ಮಾಡ್ಬೇಕಂತಂದ್ರೆ ಒರಿಜಿನಲ್ ಲೆಂತ್ ಎಷ್ಟು ರೆಡ್ಯೂಸ್ ಆಗ್ಯದ ಅದನ್ನ ಎರಡು ಏನ್ ಮಾಡ್ಬೇಕು ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಂಡು ಚೇಂಜ್ ಇನ್ ಡೆಲ್ಟಾ ಆರ್ ಮತ್ತೆ ಡೆಲ್ಟಾ ಎಲ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು. ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಂಡು ಗೇಜ್ ಫ್ಯಾಕ್ಟರ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಗೇಜ್ ಫ್ಯಾಕ್ಟರ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಫಾರ್ಮುಲಾ ಅದ ಡೆಲ್ಟಾ ಆರ್ ಬೈ ಆರ್ ಡಿವೈಡೆಡ್ ಬೈ ಡೆಲ್ಟಾ ಎಲ್ ಬೈ ಎಲ್. ಸೊ ಟೋಟಲಿ like this you have to do the examples. So next In strain gauge, we are using the uh, strain applied on the resistance of a wire. ಸೊ ಇಲ್ಲಿ ನಾವು ವೈರನ್ನು ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ಯಾವ ಟೈಪ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಯೂಸ್ ಮಾಡ್ಲಿಕ್ಕತ್ತೀವಿ, ಯಾವ ಟೈಪ್ ವೈರ್ ಯೂಸ್ ಮಾಡ್ಲಿಕ್ಕತ್ತೀವಿ, ವೈರ್ ಮೇಲೆ ಯಾವ ಟೈಪ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಚೇಂಜ್ ಆಗ್ಲಿಕ್ಕತ್ತದ ಅನ್ನೋದ್ರ ಮೇಲೆ ಇಲ್ಲಿ ಒಂದ್ ಎರಡು ಮೂರು ಟೈಪ್ಸ್ ಆಫ್ ಸ್ಟ್ರೇನ್ ಗೇಜಸ್ ಅದಾವ. ಸೊ ಲೆಟ್ ಅಸ್ ಸ್ಟಡಿ ದೋಸ್ ಥಿಂಗ್ಸ್. ಸೊ ಬಾಂಡೆಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಸ್ಟ್ರೇನ್ ಗೇಜ್. These strain gauges are directly bonded. Strain gauges are directly bonded, that is pasted, that means cemented onto the surface of the structure under study. Hence they are termed as a bonded strain gauge. ಇಲ್ಲಿ ನೀವು ಯಾವ ವೈರ್ದ ಸ್ಟ್ರೇನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಂತೀರಿ. ಸೊ ಅಂಡರ್ ಟೆಸ್ಟ್ ಸ್ಪೆಸಿಮೆನ್ ಏನಿರ್ತದಲ್ಲ ಆ ಟೆಸ್ಟ್ ಸ್ಪೆಸಿಮೆನ್ಗೆ ಬಾಂಡೆಡ್ ಡೈರೆಕ್ಟ್ಲಿ ಅದ್ರ ಮೇಲೆ ಏನ್ ಮಾಡಿರ್ತಾರೆ, ಸಿಮೆಂಟೆಡ್. ಮತ್ತೆ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡುವಂಥದ್ದು ನಿಕಲ್ ಅಂಡ್ ಕಾಪರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. 45% ಆಫ್ ನಿಕಲ್ ಅಂಡ್ 55% ಆಫ್ ಕಾಪರ್ ಯೂಸ್ ಮಾಡಿದಂತಹ ಪೇಸ್ಟ್ ನ ಏನ್ ಮಾಡ್ತಾರೆ, ಸರ್ಫೇಸ್ ಆಫ್ ಯಾವ್ದು ಸ್ಟಡಿ ಮಟೀರಿಯಲ್, ಯಾವ್ದು ನೀವು ಸ್ಟಡಿ ಮಾಡ್ಲಿಕ್ಕತ್ತೀರ, ಟೆಸ್ಟ್ ಮಾಡ್ಬೇಕಾದಂತ ಸ್ಪೆಸಿಮನ್ ಮ್ಯಾಲ ಏನ್ ಮಾಡ್ತಾರ, ಕೋಟ್ ಮಾಡ್ತಾರೆ. ಹೆನ್ಸ್ ಅದಕ್ಕೆ ಏನಂತಾರ, ಮ್ಯಾಲ್ ಕೋಟ್ ಮಾಡ್ತಿರಲ್ಲ, ಸೊ ಅದಕ್ಕೆ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಅ ಬಾಂಡೆಡ್ ಸ್ಟ್ರೇನ್ ಗೇಜ್ ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ. ಸೊ ಇಟ್ ಲುಕ್ಸ್ ಲೈಕ್ ದಿಸ್. Bonded resistance strain gauge, it looks like this. Here end loops are there, active grid length is there, solder tab, ಬೇಕಿಂಗ್ ಮಟೀರಿಯಲ್ ನಾರ್ಮಲಿ ಇನ್ಸುಲೇಟರ್ ಅಂತ ಹೇಳಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ನೀವು ಯಾವಾಗ ಸ್ಟ್ರೇನ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೀರಿ, ಸೊ ಅವಾಗ ಏನಾಗ್ತದೆ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಡೈಮೆನ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತದ, ಲೆಂತ್ ಚೇಂಜ್ ಆಗ್ತದ. ಸೊ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದಿಸ್ we are going to measure the strain in terms of resistance in the bonded resistance strain gauge. Then what are the features of bonded resistance strain gauge? They are reasonably expensive. They can pull off overall accuracy of better than plus or minus 0.10%. So they are available in a short gauge length and have small physical size. These strain gauges are only moderately affected by temperature changes. They are extremely sensitive and have low mass. Bonded resistance strain gauges can be employed to measure both static and dynamic strain. These types of strain gauges are appropriate for a wide variety of environmental condition. ನೋಡ್ರಿ ಟೆಂಪರೇಚರ್ಗೆ ಇಲ್ಲಿ ವೇರಿಯೇಷನ್ ಜಾಸ್ತಿ ಆಗುವುದಿಲ್ಲ, ನಾಟ್ ಅಫೆಕ್ಟೆಡ್, moderately affected by the temperature changes. So we are measuring the strain in an environmental condition. First thing affected by this is temperature. So here this strain gauge is moderately affected by the changes. You can use it in an environmental condition, appropriate for a wide variety of environmental conditions. So this is about bonded resistance strain gauge. So next we will move to unbonded strain gauge. These strain gauges are not directly bonded, that is pasted onto the surface of the structure under study. Hence they are termed as a unbonded strain gauges. So in this type of strain gauge are not directly bonded. ಅಂತಂದ್ರೆ ನೀವು ವೈರ್ ಫಿಲ್ಮ್ ಯಾವುದನ್ನ ರೆಸಿಸ್ಟೆನ್ಸ್ ಯಾವ್ದ್ರದ್ದು ಸ್ಟ್ರೇನ್ ಮೆಜರ್ ಮಾಡ್ಬೇಕಂತೀರಿ, ಅದ್ರ ಮೇಲೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಪೇಸ್ಟ್ ಮಾಡಿರುವುದಿಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಸಿಮೆಂಟ್ ಮಾಡುವುದಿಲ್ಲ. ಅಂಡರ್ ಸ್ಪೆಸಿಮೆನ್ ಟೆಸ್ಟ್ ಅಂಡರ್ ದ ಸ್ಪೆಸಿಮೆನ್ ಏನಿರ್ತದೆ ಅದಕ್ಕೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಏನ್ ಮಾಡಿರುವುದಿಲ್ಲ, ಬಾಂಡೆಡ್ ಮಾಡುವುದಿಲ್ಲ. ಹೆನ್ಸ್ ದಿಸ್ ಟೈಪ್ ಆಫ್ ಸ್ಟ್ರೇನ್ ಗೇಜಸ್ ಆರ್ ಕಾಲ್ಡ್ as a unbounded strain gauge. So it looks like this. This is an unbounded strain gauge. Here frame is there, Q frame is there, Q and P frame is there. Unbounded strain gauge, it is wire. Here wire is there. So unbounded strain gauge. So insulated pins are there here. When you apply force on this, it's not these wires are not directly bounded, not directly pasted. So when you apply the force on this, the material, first the force is applied to this material, after that here wire is there. when force is applied, the wire displacement and length is changed and resistance of wire this is changed. Hence, the gauge factor you can calculate it and measure. You can measure the strain like this. In unbounded strain gauge, the strain is measured in terms of resistance. The displacement of a wire is measured in terms of a resistance. Now, next let us study what are the features of unbounded strain gauge. They are able to measure strains of plus or minus 1 micrometer per meter. They are small in size and light in weight. They are able to respond to high frequency signals. They have wide range of frequency response. They have stable calibration constant gauge factor. They are flexible in use and are used in wide range of applications. They are low in cost. The cost is low for unbounded resistors compared to bounded resistors. So this is about unbounded strain gauge. So next, let us study wire type strain gauge. So the wire type strain gauges are, these strain gauges consist of grid of fine resistance wire of about 0.025 mm. So very fine 0.025 mm in diameter or less directly bonded, that is pasted onto the surface of the structure under study. These strain gauges consist of grids of fine resistance wire of about 0.025 mm in diameter or less directly bonded, that is pasted onto the surface of the structure under study. So this looks like this. Here leads are there. So this is a wire grid. This is a paper. So this is paper. This is the wire grid. So, wire type strain gauge, these strain gauges consist of grid of fine resistance wire of about 0.025 mm in diameter or less directly bonded, that is pasted onto the surface of the structure under study. So, let us go through the features of wire type strain gauges. The wire type strain gauge should have a high value of gauge factor. The resistance of a wire type strain gauge should be as high as possible. The wire type strain gauge should have a low resistance temperature coefficient. The wire type strain gauge should not have any hysteresis effect in its response. The wire type strain gauge should have linear characteristics. The wire type strain gauge should have a good frequency response. These are some features of wire type strain gauge. Now next is foil type strain gauge. Foil type strain gauges use similar materials to wire strain gauges but have greater heat dissipation capacity on account of greater surface area. Due to this reason, they can be employed for higher operating temperature range. Features of foil type strain gauges. The feature of a foil type strain gauge are similar to those of a wire wound strain gauge, except resistance value of a foil gauge are available in between 50 and 1000 ohms and maximum gauge current is about 30 milliamperes. So these are the some features of foil type strain gauge. So here one MCQ question that maybe you are getting in a CET. Strain gauge is a strain gauge is a options active device and converts mechanical displacement into a change of resistance. It is a passive device and converts electrical displacement into a change of resistance. Third option is passive device and converts mechanical displacement into a change of resistance. Fourth option is active device and converts electrical displacement into a change of resistance. So first only I am told you in first slide only. Strain gauge is a passive resistive transducer. Hence the answer for this question is passive device and converts mechanical displacement into a change of resistance. So in this session, if you have completely know about strain gauge, so frequently asked questions in exam are explain briefly different types of strain gauges. So different types of strain gauges are bonded bonded resistance strain gauge, unbonded strain gauge, wire type strain gauge and foil type strain gauge. So you have to mention these types of strain gauges. And next question is explain different strain gauges with their principle of operations. You have to explain all the strain gauges with their principle of operations. So the next question is explain briefly unbonded and bonded resistance wire strain gauges. Bonded and unbonded resistance you are going to explain for this question. So in this session totally you have studied about the strain gauge completely. The working principle, gauge factor, on that one problem, calculating the gauge factor and different types of strain gauges, bonded, unbonded, wire type and foil type strain gauges you have studied in this session. Thank you.